So we've now seen how to combine the processing system and RTL code in the block diagram flow, but now I want to get away from the block diagram and show you how you can use the processing system and implement it into an HDL only flow. What you can do is, I'm going to leave all this here for now. What you can come over here go to create a block diagram. I'll create this and call it PS only to differentiate that. Now, if you go to our sources, you can see that I now have two block diagrams. For the PS only, I'm going to go ahead and run my tickle script to instantiate and configure my processing system for the Zybo board. Then we can just go ahead and create our wrapper straight away. And Vivado then went ahead and very conveniently created an instantiation template in VHDL for me to instantiate the block diagram. And so this right here is everything I need already created and ready to go to instantiate the processing system in a VHDL file. And so now I have a .vhd here of the processing system, a .vhd here for Blinky, and I just need to incorporate both of these two in a new top level VHDL file. So I'll go ahead and create that. I'll just call this top. And then I know that for Blinky, I'm going to need clock input port and an LED output port. So I'll go ahead and do that. And now I have my top.vhd here. And so I have ports now for my clock and my LED. And now what I can do is just look at my processing system wrapper and bring all this into my top diagram. So what I can do now is I can come over here and look at and see that I need the Unisim library. So I can go ahead and copy that over. I'm not going to need that and can delete it out. And then in my top level entity, I do need all of these as ports because each of these gets broken out onto the physical circuit board. And so I need to carry these top level ports over into my top.vhd. So I'm going to go ahead and just copy and paste those in, do a little bit of formatting to make this look a little bit nicer. Right, so now I have my top level ports, and then underneath the architecture, I need to find my component, which is in this case, the name of my block diagram. So I can find my architecture, come underneath it and copy and paste that in. So I now have my component for the processing system. And then I also am going to need, after the begin keyword, I'm going to instantiate and name my component itself. So that's the processing system. And now I need to go and do the same thing with Blinky. I'm going to create separate sections just to make this a little bit easier to see. So this is processing system component definition. And then after the end component, I'm going to have Blinky component. And then same thing here, an instance of my processing system and an instance of Blinky. I go back to my Blinky module and I'm going to create a component based on this top level port. The clock and the LED are already named here in top. And so I can name my component. And I want to name this Blinky to match the name of my module over here. Ports are going to be the same as the module. And then I need to end the component. And then I can go ahead and do the same thing with my actual instance. I will name this, I'll keep the naming convention and say Blinky I, for instance. I'm instantiating my component Blinky. The names of all the components are consistent. So I have clock here and I have clock in my top level port. And so I'm tying both of those two together. And so just like here, each of these are named the same. The component port and the top level port are all the same. So that's why those are the same names in each side. With the same thing for Blinky. So I'll have clock, and LED to LED. We can go ahead and save that. And now if you look in top, you can see that I have my block diagram instantiated and I have my Blinky module instantiated. And so now we can go ahead and make this top and go ahead and take a look at our elaborate design so we can visualize all of our instantiations. All right, and so now if we look at our elaborate design, you can see that we have our processing system and we have our Blinky, and those are each independently instantiated inside of our top VHDL file. And so there's no interaction between these. In each of these cases, we have our top level ports going to each of our individual components on both the inputs and the outputs. And so if you look at our schematic, you can see that there's no interaction between the processing system and Blinky. And so that looks identical to our system when we had done all of this together on the block diagram itself, where you had the processing system and Blinky each separate and independent, which we can look at in the block diagram with the processing system and Blinky together. Hopefully that's helpful, showing you how you can take the processing system, and while you do need to start with a block diagram, it's really fast and easy to throw a wrapper around just a processing system. And once you do that, Vivado takes care of all the hard work of creating all of the inputs and output ports. You can just copy and paste this just like you would any other instantiated component into some other higher level VHDL file. And then that allows you to instantiate the processing system in the HDL flow without having to integrate all of your VHDL or Verilog modules into a top level block diagram.